Section 16.2, Serverless Applications with Spring Cloud Function. As introduced in Chapter 1, serverless is a further abstraction layer on top of virtual machines and containers, moving even more responsibilities from product teams to the platform. Following the serverless computing model, developers focus on implementing the business logic for their applications. Using an orchestrator like Kubernetes still requires infrastructure provisioning, capacity planning, and scaling. In contrast, a serverless platform takes care of setting up the underlying infrastructure needed by the applications to run, including virtual machines, containers, and dynamic scaling. Serverless applications typically only run when there is an event to handle, such as an HTTP request, request-driven, or a message, event-driven. The event can be external or produced by another function. For example, whenever a message is added to a queue, a function might be triggered, process the message, and then exit the execution. When there is nothing to process, the platform shuts down all the resources involved with the function so you can really pay for your actual usage. In the other cloud-native topologies like CaaS or PaaS, there is always a server involved running 24/7. Compared to traditional systems, you get the advantage of dynamic scalability, reducing the number of resources provisioned at any given time. Still, there is always something up and running that has a cost. In the serverless model, however, resources are provisioned only when necessary. If there is nothing to process, everything is shut down. That's what we call scaling to zero, and it's one of the main features offered by serverless platforms. A consequence of scaling applications to zero is that when eventually there's a request to handle, a new application instance is started, and it must be ready to process the request very quickly. Standard JVM applications are not suitable for serverless applications, since it's hard to achieve a startup time lower than a few seconds. That's why Grail VM native images became popular. Their instant startup time and reduced memory consumption make them perfect for the serverless model. The instant startup time is required for scaling. The reduced memory consumption helps reduce costs, which is one of the goals of serverless and cloud native in general. Besides cost optimization, serverless technologies also move some extra responsibility from the application to the platform. That might be an advantage, since it allows developers to focus exclusively on the business logic. But it's also essential to consider what degree of control you would like to have and how you will deal with vendor lock-in. Each serverless platform has its own features and APIs. Once you start writing functions for a specific platform, you can't move them easily to another, as you would do with containers. You might compromise to gain responsibility and scope and lose on control and portability more than with any other approach. That's why Knative became popular quickly. It's built on Kubernetes, which means that you can easily move your serverless workloads between platforms and vendors. This section will guide you through developing and deploying a serverless application. You'll use Spring Native to compile it to a Grail VM native image and use Spring Cloud Function to implement the business logic as functions, which is an excellent choice since serverless applications are event-driven. Section 16.2.1, Building Serverless Applications with Spring Cloud Function. You have already worked with Spring Cloud Function in Chapter 10. As you learned there, it's a project aimed at promoting business logic implementation via functions based on the standard interfaces introduced by Java 8, Supplier, Function, and Consumer. Spring Cloud Function is very flexible. You have already seen how it integrates transparently with external messaging systems like RabbitMQ and Kafka, a handy feature for building serverless applications that are triggered by messages. In this section, I'd like to show you one more feature offered by Spring Cloud Function that lets you expose functions as endpoints triggered by HTTP requests and cloud events, which is a specification standardizing the format and distribution of events in cloud architectures. We'll use the same requirements as those for the quote service application we built earlier, but this time we'll implement the business logic as functions and let the framework deal with exposing them as HTTP endpoints. Bootstrapping a new project with Spring Native and Spring Cloud Function. You can initialize the quote function project from Spring Initializer, start.spring.io, store the result in a new quote function Git repository, and push it to GitHub. The parameters for the initialization are shown in Figure 16.2.
Figure 16.2. The parameters for initializing the quote function project.
The project contains the following dependencies. Spring Reactive Web provides the necessary libraries for building reactive web applications with Spring Webflux, and it includes Netty as the default embedded server. Spring Cloud Function provides the necessary libraries to support business logic implementation via functions, export them via several communication channels, and integrate them with serverless platforms. Spring Native supports compiling Spring applications to native executables using the Grail VM native image compiler. The resulting dependencies section of the build.gradle file looks like the following.
See this code?
Then you can update the Cloud Native build packs configuration in build.gradle, much like we did for Quote Service.
Listing 16.8. Configuration for containerizing quote function.
Next, copy all the classes from the com.polarbookshop.quoteservice.domain package in Quote Service to a new com.polarbookshop.quotefunction.domain package in Quote Function. In the next section, we'll implement the business logic as functions. Implementing the business logic as functions. As you learned in Chapter 10, Spring Cloud Function enhances standard Java functions when they are registered as beans. Let's start by adding a Quote Functions class and a new com.polarbookshop.quotefunction.functions package for the Quote Function project. The application should expose similar functionality to Quote Service. Returning all the quotes can be expressed as a supplier, since it takes no input. Returning a random quote can also be expressed as a supplier, since it takes no input. Returning a random quote for a given genre can be expressed as a function, since it has both input and output. Logging a quote to standard output can be expressed as a consumer, since it has input but no output.
Listing 16.9. Implementing the business logic as functions.
Spring Cloud Function will automatically expose all the registered functions as HTTP endpoints when the Spring Web dependencies are on the class path. Each endpoint uses the same name as the function. In general, suppliers can be invoked through GET requests and functions, and consumers as POST requests. Quote function contains the Spring Reactive Web dependency, so Netty will be the server to handle HTTP requests. Let's make it listen to port 9102 and configure the application name. Open the application.yml file and add the following configuration.
Listing 16.10. Configuring the Netty server port and application name.
Then run the quote function application ./gradle boot run and open a terminal window. For starters, you can test the two suppliers by sending GET requests.
See this code.
To get a random quote by genre, you need to provide a genre string in the body of a POST request.
See this code.
When only one function is registered as a bean, Spring Cloud Function will automatically expose it through the root endpoint. In the case of multiple functions, you can choose the function through the spring.cloud.function.definition configuration property. For example, we could expose the allQuotes function through the root endpoint. In the quote function project, open the application.yml file and update it as follows.
Listing 16.11. Defining the main function managed by Spring Cloud Function.
Rerun the application and send a GET request to the root endpoint. Since the allQuotes function is a supplier returning a flux of quote, you can leverage the streaming capabilities of Project Reactor and ask the application to return the quotes as they become available. That is done automatically when the accept text event stream header is used. For example, curl h accept text event stream localhost 9102. When using the HTTP utility, you'll also need to use the -- stream argument to enable data streaming.
See this code?
Similar to what you did in Chapter 10, you can build a pipeline by combining functions. When functions are exposed as HTTP endpoints, you can use the comma character to compose functions on the fly. For example, you could combine the genre quote function with log quote as follows.
See this code?
Since log quote is a consumer, the HTTP response has a 202 status with no body. If you check the application logs, you'll see that the random quote by genre has been printed out instead. Spring Cloud Function integrates with several communication channels. You have seen how you can expose functions through exchanges and queues leveraging Spring Cloud Stream and how to expose them as HTTP endpoints. The framework also supports RSocket, which is a binary reactive protocol, and Cloud Events, a specification standardizing the format and distribution of events in cloud architectures, cloudevents.io. Cloud events can be consumed over HTTP messaging channels like AMPQ, RabbitMQ, and RSocket. They ensure a standard way of describing events, thus making them portable across a wide variety of technologies, including applications, messaging systems, build tools, and platforms. Since quote function is already configured to expose functions as HTTP endpoints, you can make it consume cloud events without changing any code. Ensure the application is up and running, and then send an HTTP request with the additional headers defined by the Cloud Events specification.
See this code?
When you're done testing the application, stop the process with Ctrl-C. Note: you can refer to the Spring Cloud Function official documentation for more details on how HTTP, Cloud Events, and RSocket are supported. See this link. Section 16.2.2, Deployment Pipeline, Build and Publish. Following the continuous delivery principles and techniques explained throughout the book, we can implement a deployment pipeline for quote service and quote function. Since the release candidate for those projects is a container image, most of the operations will be the same as for standard JVM applications. When working locally, it's convenient to run and test serverless applications on the JVM rather than using Grail VM due to the shorter build time and the less resource-demanding process. However, to achieve better quality and catch errors earlier, we should run and verify the applications in native mode as early in the delivery process as possible. The commit stage is where we compile and test our applications, so it might be a good place to add those additional steps. In your quote function project, quote function, add a new .github workflows folder and create a commitstage.yml file. As a starting point, you can copy the implementation of the commit stage from one of the other applications we built in the previous chapters, such as Catalog Service. The commit stage workflow we have used so far is composed of two jobs: build and test, and package and publish. We'll reuse the implementation from the other applications, but we'll add an intermediate job responsible for testing the native mode.
Listing 16.12. A job to build and test the application in native mode.
Note: in the source code repository accompanying the book, you can check the final result in the Chapter 16/16n/quote function folder. When you're done, commit all your changes and push them to your GitHub quote function repository to trigger the commit stage workflow. We're going to use the container image published by that workflow later in the chapter, so make sure it runs successfully. You'll notice that the commit stage execution for quote function takes quite a bit longer than for the other applications throughout the book. In Chapter 3, I wrote that the commit stage is supposed to be fast, possibly under 5 minutes, to provide developers with fast feedback about their changes and allow them to move on to the next task, in the spirit of continuous integration. The additional steps using Grail VM that we have just added might slow down the workflow too much. In that case, you might consider moving this check to the acceptance stage, where we allow the overall process to take longer. The following section will cover some options for deploying serverless applications implemented with Spring Cloud Function. Section 16.2.3, Deploying serverless applications on the cloud. Applications using Spring Cloud Function can be deployed in a few different ways. First of all, since they're still Spring Boot applications, you can package them as jar artifacts or container images and deploy them on servers or container runtimes like Docker or Kubernetes, respectively, just like you did in the previous chapters. Then, when Spring Native is included, you also have the option to compile them to native images and run them on servers or container runtimes. Thanks to instant startup time and reduced memory consumption, you can also seamlessly deploy such applications on serverless platforms. The next section covers how to use Knative to run your serverless workloads on Kubernetes. Spring Cloud Function also supports deploying applications on vendor-specific fast platforms like AWS Lambda, Azure Functions, and Google Cloud Functions. Once you choose a platform, you can add the related adapter provided by the framework to accomplish the integration. Each adapter works in a slightly different way, depending on the specific platform and the configuration required to integrate the functions with the underlying infrastructure. The adapters provided by Spring Cloud Function don't require any changes to your business logic, but they might need some additional code to configure the integration. When you use one of those adapters, you must choose which function to integrate with the platform. If there's only one function registered as a bean, that's the one used. If there are more, like in quote function, you need to use the spring.cloud.function.definition property to declare which function the FAS platform will manage. Note: you can refer to the Spring Cloud Function official documentation for more details on the Spring Cloud Function adapters for AWS Lambda, Azure Functions, and Google Cloud Functions. See this link. The following section will cover deploying a serverless application like quote function on a Kubernetes-based platform using Knative.